All right, guys, I'm going to take a little bit of time and talk through this Module 4 activity that you guys had due. So here we go. So question number 1 says, for accounting purposes, a local construction business depreciates, which means decreases, the value of a piece of machinery at a constant rate each year. Oops, don't really need that part. Let V represent the value of the machinery in dollars and T represent the number of years owned. So the first part says to determine the constant rate of change and explain its meaning using the problem context. So if you guys know me by now, you know that I'm going to make a table. So T and V, and I'm going to put those 2 points in my table. And then the CROC is just the change in output over the change in input. So I need to find those changes. So my change in input is going to be 3. My change in output, if I do 20,500 minus 37,000, I'm going to get negative 16,500. And so my change in value over change in time is going to be 16,500 over 3. Really, the units there are dollars and years. And so when I get this, the units here are going to be dollars per year. And so really that kind of tells me what the main meaning is we would say the value of the machinery decreases by $5,500 per year. All right, part B says to create a linear function that gives the value of the machinery with respect to the number of years owned. And so it doesn't, essentially we have that general form of a linear function that I'm going to use. We have our CROC. We just need to pick one of the 2 points as our reference point. And so if I were to pick the first one, here's how I would write it. All right, so maybe you write your formula this way. If you pick the second one, and note you don't need to do both of these. All right, just pick whichever one you want. You would write it this way. So just give me one of those. I'm just giving you both right now so you can see the difference. For part C, it says use the function to determine the value of the machinery after 8 years. So let's say I use the first one. So essentially after 8 years, right, that's when T is 8. I'm going to get this. So really essentially what this is saying is, okay, it's been 6 more years. Every year it goes down $5,500, and so negative 5,500 times 6 gets me negative 33,000. So in 6 years, the value goes down 33,000, but it was already 37,000, so my value remaining is 4,000. For part D, it says now determine the number of years the machinery has been owed when the value is listed at 26,000. So 26,000 is my value, which is my output. I'm going to use my first formula again. And now I just need to solve for T. So I would subtract 37,000 from both sides. When I do that, I get negative 11,000. Equals all that. Divide both sides, divide both sides by negative 5,500, and I'm going to actually get 2. And so then when I add 2 to both sides, I get 4. So after 4 years, the value is $26,000. All right, so that's question number 1. Question number 2 is actually very similar. We just don't have any context. So we have 2 quantities, x and y, related by a constant rate of change. We have these 2 coordinate points that fall on the line of the graph. So x is my input, y is my output. I'm going to make a table. It doesn't really matter which order you put these points in the table. I tend to write them so that my inputs are increasing. That's just kind of like in math, that's how we do it. It doesn't matter though, because if you switch it, it's going to switch the sign of both changes, which ends up kind of canceling itself out. So I still need to find the change in input and change in output. So I would need to do 2.4 minus a negative 5. And so I'd get 7.4, which makes sense because my input increased. For my output, I would do 6.82 minus the negative 43.2, and I'm going to get 50.32. Then I would need to do my change in output over change in input. So 50.32 over 7.4, and I get 6.8. So this is my CROC. And so then again, I'm going to write my formula. I tend to pick the reference point without negatives in it, if there is one, just because that way I don't get mixed up with my signs. So I'm going to pick the second one and write it like that. And this is my formula. All right, let's keep going. Question number 3 says the constant rate of change of W with respect to X is negative 3.2. and -3, -2 is a point on my graph. So remember when it says something like W with respect to X, this is saying output with respect to input. So we know that my formula is going to be W equals something. So my croc is -3.2. If I were to write it kind of just like I see it, I would write this because my reference input is -3. More often, right, we would just take that x minus -3 is the same as x plus 3. So it doesn't matter, again, which way you write it, but know if you see this, that reference input is really -3. So just be careful. Question number 4 says, recall the following problem. The graph given below represents the number of miles a gas tank is until empty with respect to the number of gallons used. All right, so we have a constant rate of change. This problem, by the way, I believe is from the Module 2 homework. But just in case we forget, Part A says to write a linear function that gives miles to empty m with respect to number of gallons. So again, I'm going to make my table. So 5.2, 275.2, oh no, 9.5, and 172. Oops, 2. I'm going to find my change in input, which is going to be 4.3. I'm going to find my change in output, which is going to be -103.2. Assuming I did that right. So then my croc is going to be the change in m over change in g, so -103.2 over 4.3, and we get -24. The units on that are going to be miles per gallon, by the way. So then I just need to pick one of my 2 points as my reference point. If I pick the first one, I would write the formula like this. Oops. Like that. So that is my formula. Then part B says to use my function to determine the number of miles to empty when you've used 12 gallons. So I'm going to take that function. I'm going to input 12. And I'm just going to simplify. And when you do that, you're going to get 112, and the units on that would be miles. So if you use 12 gallons, you have 112 miles, so you have to till it's empty. Part C says determine the vertical intercept and explain its meaning, and then plot it. So remember, vertical intercept is always going to happen when my input is 0. So I'm just going to take that function, just like I did in B, and now input 0. And when I simplify this, I'm going to get 400. So my vertical intercept is 0, 400. A vertical intercept is always a coordinate point, so don't just tell me it's 400. And essentially the meaning is that when you've used 0 gallons of gas, you have 400 miles till empty. All right, part D is similar except horizontal intercept. Horizontal intercept, now the output is 0, and we're trying to find the input. So for example, my first step would be to subtract 275.2 from both sides. And so when you do that, you get this. And then divide both sides by -24, which is going to give you 11.47 equals G minus 5.2. If you add 5.2 to both sides, you're going to get G equals 16.67. So my intercept is going to be 16.67, comma 0. So the input of 16.67 is going to result in an output of 0. And so essentially what that means is when you've used 16.67 gallons of gas, you can go no farther. Your tank is empty, I guess I'll say. All right, so part E, by the way, on my graph, sorry, I can connect these, right, because really this is what's going on. Ooh, magic. So when I list my practical domain, essentially remember domain is looking at inputs. So if I'm looking at inputs, I'm looking at this axis. So essentially my domain is going to start here and end here, because it doesn't make sense to talk about using a negative number of gallons used. But if I use more than the 16.67, then it says I have negative miles till empty, so that doesn't make sense. And so I'm going to use inequalities and express it this way. So the number of gallons used can be between 0 and 16.67. The range is similar, but now we're looking at outputs. So it's going to start there at 0 miles till empty, and the max is going to be 400. So I'm going to write it like that. All right, keep trucking along. So a 6-year-old begins saving money in his piggy bank. His parents added some money to help encourage him. M represents the amount of money in his bank. It should say in dollars. N represents the number of weeks he's been saving. So we have this function, and then we need to first identify the constant rate of change. So the crock is going to be here, and the units on that are going to be dollars per week. So essentially every week he saves $2.50. Good job, buddy. My reference point is going to be 5,37.5. And so what that means is after 5 weeks, he has $37.50. I really need to do something like that. All right, I'm kidding. Am I? I don't know. All right, problem number 6 says for each of the following, identify the crock and the reference point. So for part A, the crock is 4. For the reference point, it's going to be 2.1, comma 16. For B, the crock is 1.9, and the reference point is going to be a negative 12, negative 14. So you just have to be careful. If that's a plus, really it's minus a negative. All right, so then that leads us to number 7. Suppose A and B are related by a constant rate of change of 5.7, and so this relationship is true. Use it to find the unknown values in the table. So if I want to find the output when the input is negative 2, my first step is to find this change from here to here. So I would do negative 2 minus a 1.2, right, to find this change. So that's my first step. And I'm going to get negative 3.2. My second step is to essentially use this to find my corresponding change in output. And so my second step is to do 5.7 times the negative 3.2, and we're going to get negative 18.24. Right, that's my second step. Because if my input is decreasing, my output should also be decreasing. And so then my third step is to say, okay, well, it was 0.84, but it's decreasing by 18.24. And so now we get negative 17.4. And so that is my answer right here. All right, we can do the same idea to get this next one. So step 4, let's say, is to do 4.5 minus 1.2, and I'm going to get a positive 3.3 because my input is increasing. And then same idea, I'm going to take my crock times now my change in input. I'm going to get a positive 18.81. So this is step 5. I'm going to add the 18.81 to the 0.84. That was my reference output. And I'm going to get 19.65. So this is my answer here. And then on the last one, so I'm going to use this bottom reference point just because it's closer. This last one is going to kind of go, by the way, that's step 6, in the opposite direction. So the first thing I need to do here is find my change in output. So 72.09 minus 39.6, and I'm going to get a positive 32.49. So my 8th step is now I need to find my change in input. Instead of multiplying by my crock, since we're working backwards, we are going to divide by my crock. And I am actually going to get 5.7 as my change in input. And so my very last step is to take my reference input, add my change in input, and we are going to get our new input. So that is how I would answer question 7.